Okay. Felix, what was
Yes.
happening that our output in our test function, we had two tests. We are testing with the real printf and the fake printf. So they didn't get the same results.
All right. So let me pick up from there. Now, I've already written something here. I don't know how far I wrote before, but this is what happens now. It enters here. It picks the first. This is a loop, so it keeps going through the. Am I still audible, guys? I think I'll be asking at intervals.
Right? Yeah.
Audible. Okay, I'm here. All right. So it will enter the loop at line 16, and then it will write the character it sees onto the standard output. It will come back again. It will increment I by 1. Then it will go back into the loop. It will keep doing that until we hit the null byte, which C adds for us automatically. And then it will now step out of that loop and then enter line 22 and return 0, which is what's going to happen. So let's compile and see that. So we are going to be building gradually and testing. If you don't test, the problem you will have is you will do so many things, and then just one thing will make you have to rewrite the code again, or just give you too much headache. So take it one step at a time. So let's go back and test it and see whether it runs. Call DCC again and compile. Error. Ow. Okay, what does it say? It said implicit declaration of function right. Okay, I did not put the header file for that in that place, so I'm going to go back into that function and put the header file, which is standard, what do you call it again?
UNI.
Yeah. Uni std. All right, I'm out. Compile again. See our errors. If they, oh my God, it says passing argument 2 of right makes pointer from integer without a cast. Whoops! Who makes sense of that? Let me try. Okay. I understand what's happening here. I hope one or two other persons understand. If you pass an integer without a cast, then we have a problem because it's supposed to receive a character. Passing argument Q of right makes pointer.
I thought. Don't you use the stdio.h as well? That this is one of your errors that you're getting.
Okay, let me just get back into the file. Let me get back into that stuff. Good. Okay, you say what?
stdio.h. Why aren't you including the standard input output?
Why I do not include it is I've never had any need to use that. I've never used any function from the standard IO. So I don't like including things that I don't need.
Okay. Because I was thinking that's why the error came up.
Okay, now I've understood where the error came from. Now, guys, please watch. In case you will use right in the future, this function, right? Right does not take. Right does not take a character. It's supposed to take a pointer. It doesn't actually take the character. It takes a pointer to a character or pointer to characters. So when you do something like this, when you say, with respect to the string I have up here, when you do something like format I, this returns, if it is 0, if I is equal to 0, okay, let me put here, I is equal to 0 at this instance, and you do, this returns S. True or false? Somebody give me feedback. True, yeah?
Come again. I didn't get that very well.
I said
yes. You are correct.
Okay. I said with respect to this string here, if I is 0 and I do with our function format I, it should return S. But what writes X is not a character S. It takes a pointer, character pointer. So format I is not a pointer. Format I is actually returning the character. So we have to give this point an address, like not character itself, but an address. So there are two ways we can do that. We can just add the address sign in front, the ampersand, yeah, and then that should solve that. Or we can do what we call pointer arithmetic. See how all those concepts we talked about are coming to play now. We do the pointer arithmetics and do something like this. We remove this. Remember, the name of an array returns the address. So we do something like this. Format plus I. So wherever I is, it will just add, and this will also work. So this is another way to fix it. But since I was doing it the array way, let's continue with the array way. If I do compile this, it will work. If I still do it the other way, it's still going to work. So let's still do it the array way so that it doesn't confuse people. So I'll remove this and I'll do ampersand format this. So at this instance, what it is returning is address to where S is stored. So this returns S, but this is returning pointer to S. So that's what write function wants, not the S itself. Okay. Now I'm going out to compile again. I'll have to clear out all this thing. And I'll call GCC one more time. And compile. Are we successful? Well, we are successful. So it worked. It worked. It worked. So, what did you say?
Let's see A out so that we are happy.
All right, so let's test it and see whether we have. So I'm going to run the output now. Beautiful. So, guys, can you see what's happening now? Standard has brought back tester, which is the normal printf, and our own function, our own homemade function, has also returned tester. A round of applause for us. All right. Okay. It's all right. It's all right. Thank you. Thank you. Thank you. So, is anybody lost thus far? Any questions? Quick one. Let's proceed.
Let's proceed.
Okay, in the absence of any questions, I'm going to clear out and let's get back into our.
Oh, could you?
Yes.
Okay. I didn't quite understand the like how you actually use the tester. I followed you for the coding of the printf and the other function, but your main.c files I don't really understand it.
Please take a look quickly. Just scan through it.
Okay, I've seen it already. Thank you.
Can you please throw up there?
There's no up. This is all there is. This is all there is. All right.
Let's continue this.
Continue. Now, there's another challenge. And we have to fix that. Printf returns. We haven't actually considered the return value. Printf returns a value. Now, printf is supposed to return the number of characters it printed. Yeah? The number of characters it printed. That's what it's supposed to return. But I don't know. Let me just put it like this. I don't know whether our own will be able to do that. But I know that the regular printf, the standard printf, will do that. So we'll have to write a test first. Then now, pass mic on, please. Just mute. Please, mute microphones. Someone still has microphone on. Thank you. All right, so the standard printf sends out a return that is the number of characters it printed. I don't know whether our own would do that. So let's test it. So I'm going to include it in our tests, and then we'll implement it. If it shows up in the test, good. That means magically it was implemented. But if it doesn't show up, then we have to work on that. That's another step. So on this test file, I'm going to modify it. So I am in our main.c file. Now, up here is the standard case. Now, let me add something else here too. Just a line demarcator to demarcate, differentiate between the other one and the other one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25, which is new line character. So I'll put 25 here. All right, this goes here. So this is just supposed to print lines. Let's print lines. Just now, I am going to extract the return statement of our first print and then print that return statement. It's supposed to return an integer. Yeah. So let me declare an integer or two integers. One will capture the return from the standard printf, and the other integer will capture the return statement from our own printf. So I'm going to call this int count std, which is for the standard one, equals to 0. And then I'm going to declare another integer, call it count homemade equals to 0. And then I am going to use that, what I declared, to capture the return value from printf on line 18. I'm going to use it to capture the return value of printf on line 18. So I will use the one for count std. So count std is going to capture that output. And then this one on our own side on line 23, count homemade, count underscore homemade will capture the return number from our printf. Now, how do I know that that is captured? I'm going to still render it again. Now I'm going to use the regular printf and render it so that it should be easy for us. Printf, I printed dash characters, dash %d characters, just to have it in a statement form. Then I'm going to feed in count std to it. That should handle that. Then on this other side, I'm going to do the same thing. But this time around, I'll be feeding in homemade, std homemade. Okay. So in this case, I've modified the test file so that when it prints, it now checks whether there is a return value and then prints that return value, because the return value is actually supposed to be the number of characters printed. So it will print that return value. Now, in this other case, if there is a return value too, it will print it. So let's now run it again. Guys, you saw what I did there, yeah? Someone should please confirm.
Yeah.
All right.
Yeah.
So
Yes.
I'm going to compile. going to compile quickly and then run it again. Compile, good, it compiled, and I'll run and see how our tester works. Oh. There's something that happened here. That is another full day lecture, but let me fix it. It really doesn't have anything to do with what we're talking about now. Let me just get in there. Now, this will be handled with a special function that is called flush, but since we've not used that before. I read about it one of the times we were doing one of the code tasks. So I may not bother anybody. Okay, I think this should fix it now. Right. Let me clear the screen again, compile the second time, and run it. Okay, guys, this is our output. Standard printed tester, and then it now said I printed 7 characters. So if you count tester should be 7 characters. But homemade, we were successful to make it print tester, but, oh, sorry, I didn't even add a new line for that one. Let me add it too, quickly. Okay. Okay, I run it again. All right, so it's clearer now. I printed 7 characters for standard. I printed 0 characters for homemade. So another problem has just come up. And programmers, we have to fix it. So we have to make our print function able to return the number of characters it printed no matter what. So the problem has to be fixed inside the printf function. So guys, all of us will head back into the printf and fix that and build that into our function. So here we go. All right. So the situation here is that each time it goes, it just increases the index.
Oh, please, can you scroll up for the printf?
This is all there is for now.
No include statements.
Okay, let me get there. What I'm supposed to do, which anybody can just come up with that, is whenever each character is rendered to the standard output, a variable should be there to be doing the count. Have you sent 1? Yes. Oh yeah, 1. Have you sent another one? Yes. 2. Have you sent another one? Yes. 3. Have you sent another one until you finish? You say, oh, you sent 7 characters. I may not really bother about having to do count each time, because what if we encounter a situation where write is sending out more than one character? So if I do count plus is equal to count plus one, I would be wrong, because write sent out two characters, and now I am counting only one. So it is better to use the count, the number that is returned by the write function. Yeah? But if we still do it the way it is on the screen, it will still work for now, because I don't know how complex this whole build will get into. So let's do it the right way. So I'm going to use count and fetch the return from write. So count will fetch the return from write, and then that return will now be infused into the count variable. So count will now be equals to how do we do that now? No. Count cannot still do the same thing. I need to get another value. Let me get another variable, say value, because this should be changing. So value is equal to 0. So value will get what write has to offer. Value will get it, and then add it to count. That makes more sense. Let me render it the simple way so that it doesn't confuse people that are still trying to understand how this thing works. All right, so count will be equal to count, whatever count was, plus whatever value brought in. So originally count is 0. So when write on line 21 prints out, it will send the value of the number of characters it printed to value, and value will now be 1, and it will add it to 0, which is now 1, so count will be updated to 1. Now, the last thing we should do is we should return that count, not 0 this time. So we return count to the screen. Count. And that should solve this problem. So guys, is anybody lost thus far? So now we have our... What?
Honestly, I want to be honest with you.
Come, I can't hear you, please.
I say I'm lost. You ask if anybody were lost. I'm lost.
I think he's trying to say we are lost. We are lost.
So where were you lost? Quickly, let's find you. There has to be somewhere you got lost.
Brother.
If you get lost,
can you just explain from that particular? In fact, this whole thing is doing like.
Don't worry. Go ahead. Ask your question. Go ahead quickly. Let's see how we can help you as fast as possible.
There's something you mentioned about this value right here and right now. Can you come again? Let me know if I can catch it up.
Okay. I said that write function by default has a return type. It returns something. When it writes to standard output, it returns a value. For every function that is declared, there's always a return type. Yeah? And that return type can be fetched with an equals to sign, something. In this case, that something is the variable called value. So when this thing prints, it returns a number. And that number is the number of things he actually printed or he wrote to the standard output. So that number and assign it to this value. So we have a variable called count. So count is the variable that will control what is returned by printf, which is actually the number of characters printf function returned all together or sent to the standard output or to the screen. So, mute mic, please.
Your mic from Alaska.
Okay, so write where this came from. I don't know if let me pull up this one quickly and see if I can man right and right. If I do this, you will see the man page for right. I just want you to know where it's coming from so that you won't be like I'm preaching here. You can consult it later. This is the right function. Man2. So if you look at the man page, you will see what I'm talking about. So this is how you get to understand. You may not know all the functions in your head. You cannot memorize all of them. Sometimes you get into trouble with some. You go and look up the man page. So in this case, this is a prototype. Right function takes in a file descriptor, which is a number, takes in a character pointer, which is this is a pointer. That's why we had issues that first time, and takes in another size t count. Now this size t type is an integer. So this guy takes in and returns a size t type, s size t signed size t, which is still an integer. So it returns something. So that something it is returning is the number of things it printed on the screen. So that's what we are capturing with the variable value. We capture that number with value. And our count is increasing now. So count was 0 originally on line 16. But now we want count to be equals to what count was before plus whatever value is holding. So count was 0 before, so it's 0 plus 1 in this case because value will return 1. So 1, which is count, will now become 1. And then we now send count out from the return statement. Just understand what I just explained. Maybe later on, you may not get it all now, but follow the process. Later on, you can look at it critically. Does that make a little sense? At least the much that can carry you along with the rest of what we're doing.
Yes, thank you.
All right. So
hello.
Let's proceed. Yes.
Excuse. So why do we need the extra variable value when we can just show the return value in count without needing an extra variable?
Why I did that is I'm trying to see into the future. Because in a case where count is, when you return straight to count, you overwrite count each time. Remember, this is a loop. So if you return to count, you overwrite count each time. So if count was 7 and then you return 1, you have overwritten 7 to 1. So that's not what we want. So we want to be increasing count. So we need another variable that will be holding each thing that comes out from right. Do you get my point now? That should answer that.
Well, if right will be returning nothing, then the return value will return. So there's something else will be added to the count after this.
Okay, go ahead. I don't get that.
Okay, so my question basically, if right will be returning nothing, since it has a return value, it will still be stored in the count. So just for the clarification of the extra variable value, why do we actually need it? Because we can just overwrite it, or we can even not initialize count and just store it inside of the output, the return value of the right, and then yeah.
If we don't have this, if we don't have value, a temp, it's more like a temporary. I could have called it temp, TMP, just a temporary storage that will hold, because right in this case is 1 character. What if in a case where right is 2? Maybe we are working on the more advanced features of Printf and then we want to declare it such that right puts out 2 characters per time. How do we rectify that? Because here the assumption is this time right is printing 1 character. I don't like those kind of assumptions. In the future, if you want to expand the program, you will run into problems because you have to rewrite everything again. So just make provision for unforeseen circumstances. Since it's not a pain in the ass now, we can still go ahead with this and it doesn't cause any complexity issue.
Yeah, it's clear. Yeah, clear.
All right. Okay, so let's test this quickly and get on to the next problem. I'm clearing the screen. I'll compile. I hope we don't have issues. Beautiful, we didn't have any issues. And I'm going to test it. All right, guys, I think we're successful. Standard printed tester, I printed 7 characters. Our homemade printed tester, I printed 7 characters. So we have solved that problem, at least for now. Now, what is the next problem? Please, who has an idea what else Printf does from task 0 that we should start considering? I'm not seeing that here. Somebody should just pick it up and mention it. Let's work on that quickly. Our time is fast spent. I think we still have like 20, 30 more minutes. And then we call it a day for today. And I'll push whatever we've done thus far, all the codes here, I'll push it to my GitHub page. You can copy from there, continue building from there, or wait for the next session. But we'll definitely find a way to complete the tasks, all the mandatory tasks, at least before the first deadline. Then the second deadline, if we have the time, we can now do all the advanced tasks as much as we can. But if we don't have the time, then we will all take it as personal projects. Okay, so what is the next thing we are supposed to consider here, guys?
You were supposed to drop your GitHub.
Yeah, I will before this session is over. Guys, what are we working on again? Any idea?
Somebody say special characters now.
Okay. The special characters we are looking for majorly now is
character, string, and percent.
Yeah. We're looking at okay, so we're looking at characters, we're looking at strings, and we're looking at percentage, and these are all called file specifiers. But all right, so let's get into that. So what's the logic here? Getting into VI. Now, what of in a case where person sends in a null character, a null string, just sends in null as a string type? I think we have not fixed how that will be handled. Did we fix that? No, we didn't. We haven't. So we have to find a way to rectify that. Now, also, we have to find a way to handle all the special. So as we are looping through, if we have, fix that. If somebody sends in a null byte, a null pointer, please stop the program and get out, because there is nothing we're going to be doing with that. So let's have that at the beginning. If format for any reason is null, please get the heck out. There's an error. It's more like saying there's an error for now. Return -1. I think they specify that when the program is successful, return the number of characters. But if it is not successful, return -1 or a negative character. So let's use -1 for now. This should handle all of that. Now, when you're writing your code, always, I like documenting. Just writing out my algorithms. This should, let's just do print each character of string. All right, so that is all for this. Do we have any other place where we need to put? No, nothing for now. So I did something here. I have to also comment it. I have to ensure that prevent passing a null byte, null pointer. Okay. So this would prevent passing a null pointer. So while someone is reading through this code, you will know what is happening. Okay, so the next thing, let me now bring it up, is now we have situations where we now need to specify something. Say, I'm working on string, and I say string fun equal to something. We need a value. Just put percentage something, percentage D, percentage C, or something. Just let me use D for now. And then we now have to put whatever value that represents. D is for decimal type. So in this case, we have to find a way to capture that. Now, this is the logic. This is the logic, guys. While our loop structure is going, it goes string S, it goes T, it goes R, it goes I, it just keeps looping, and then whenever it hits a percentage sign, it's a signal that something should happen. So we have to do two things now, just two things for now. We have to find a way to signal the arrival at a percentage sign first, and then we also have to figure out how to fetch whatever value this person is sending in. So fetch hits when you hit a percentage sign, just signal that I have hit a percentage sign. What else can I do? And then we also have to deal with fetching variadic functions, fetching them. That's where the concept of variadic functions come in. So anytime it keeps looping and it hits this, just know that it is time to do something else. So if it looks the next place and it sees something it should fetch, then it goes to fetch it, and then prints it and continues the loop structure. So assuming string 1 is equal to D and stop it, something like that. That means, what this means is it doesn't actually stop here. Whenever it sees this, it looks at the next string or the next character. If it sees something it should work with, it goes and fetches from the variadic functions, comes back into the loop, and continues looping like nothing happened. So that is, it looks simple, but it's a process. So first, let's make the function to stop whenever it hits a percentage sign. How do we do that? It has to happen within the while loop. So while format is equal to I, I can put it in here. If I put this inside, if format I is not equal to its character, and continue to do what you're doing. So you have to indent this, then this. See how I'm building on what we already did? So you don't have to bother about the whole full picture at the beginning. It messes with your brain. Start simple. So now, this loop will continue until the loop on this line will continue until the entire string is passed. But within that loop, we should check that each time we encounter a character, that we will just run and print that character if and only if that character is not a percentage sign. If it is a percentage sign, that means something is about to happen. We don't know what that is yet, but let's first stopping at the percentage sign. So at this point, I'm going to say that if format is format I is equal to character percentage, then a set of things should be done. Question. All right, I think we have fixed that. So let me be sure that this works. So let me just say here, let me just put the regular printf from our standard library. It's printf, just to be sure that we have arrived at this point. Printf, I have encountered percentage and with a new line. That should be that for now, so that when we're sure this structure is okay, then. But aside that, now what that will mean is this: whenever we go through this first part and we finish printing and we increase this by 1, we should not go and continue checking. Once this is true and it enters here, then that means this will not evaluate eventually. So let's just stop at this point and go back to the loop, to the beginning. So I can put a continue here, and that should take care of that. Does semicolon come in front of continue? I think it should. I don't know. I don't remember. But it should, yeah? Who knows? Who remembers?
Yeah, it does. It does.
It does. All right. So that is what will happen. So now, this is the logic here. Let me compare it with what we have here. If it keeps going and passing through the text, and it hits a percentage sign, it will enter this place and print, I have encountered a percentage sign, and stop for now. Then if this is working, we'll now, but if not, once it enters here, if it goes into this place, let me still put the line number so that I will be able to be making reference to that thing. It helps. Set number. So if it goes into the if statement on line 26, it will just finish printing and then it will continue. That means you just send it back to the beginning of the loop and go again. Just keep going. So the only time it will come into this loop, if statement of line 34 is if it sees a percentage sign. So let's go back to our test.
Sorry, Felix.
Yes.
Shouldn't there be something in front of the percentage sign? Because if you have, like, say, 100%, then it shouldn't stop at the 100. You know what I mean? There should be a character in front of the percentage sign to show that it's a special.
Yes. Something like this, like an escape character, yeah. What you mean? On what
but
line?
You know, if
line what?
So if you have a string, I got 100% on my test, right? Then the printf shouldn't end at the percentage sign. It should show the percentage sign. Do you know what I mean? But if you have percentage D, then that indicates that there's a special character.
Yes. I get your point. The thing I want to establish here why I'm doing it like this is, all of us haven't, we don't understand things at this. I would have bundled everything together here, but I just want to break it down step by step so that for somebody who is trying to understand what's happening, you get to see how we arrived at the bigger picture. So I get what you're trying to say. We'll handle that later. After now, what it would do eventually once it hits the percentage sign. But I just want to be sure that it actually sees that percentage sign and just hits it. You get the point?
Okay, understand.
Yeah. Here. So let's see what happens. Q. I used printf, regular printf. So I need that on my. That's a temporary arrangement because I really don't need printf here. But let me just include standard input. Include standard io.h. You don't really need printf. I'm just using that as a test case. So I'll remove it afterwards. CC, conversion type, blah, 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 blah. What's happening here? Okay, I think I get the gist. We are still going, this is another thing printf does, so we are still going to factor all these things into our design. But I don't think it's for the mandatory task. I think those ones will come at the advanced level. So I'm going to escape this so that it doesn't actually look at it as a special thing.
Are you there?
Oh, network again. Sorry, guys. I'm still having this issue. What's happening here? What am I missing?
I think you need to put a space in between.
Okay, let me try space. Okay, like this, yeah?
Yeah, something like that.
Okay. Let's see how that works. You see, it's giving me the same error. Unknown conversion type character. Oh, it wants me to put a conversion. That's okay. Let me do something different. There's no time again. Let me just do something different. Let me clear out. I know why this is happening, and we are going to do this. We are going to implement this in our own program. It can be very painful to work with, but let me just, instead of printing this thing, let me just say there is a cent. Yeah, that should solve that. For now, I compile. When I compile, good, and then I go to main.c, and I just try to get a test file that fits that thing. As for our own homemade, I'm going to put a percentage sign somewhere. And percentage here. Okay, that's okay. All right. Where are you now, dude? Either out. Woo! Okay, it says I encountered the percentage sign and there is an infinite loop. So that's a problem. See that, guys? we have been able to encounter a percentage sign, but there is an infinite loop. So we have to figure out why that is happening. Because
I think it's because you forgot to put the base case.
Okay. Let me get back into that function. Now I am a little bit tensed because we have so little time now, and we have very much to do. Okay, where, who was saying something?
I think when they by the second if statement, you just put the break statement at the bottom.
Yeah, beautiful. Thank you. God bless you. That's I missed out. See, brains are pulling resources together. Who asked me the question? How are we going to do that? Now we're doing it. Okay, there's a break here. Yeah. So that should fix that. Then I compiled for the last time, and I run the file. Okay. So, guys, see now what happened. Remember, in our test case, I put test, and I put percentage, and then I put some other thing at the end, S. So when he wrote the first one T, he wrote the second one E, he wrote the third one S, he wrote the fourth one T, and then it encountered the percentage sign, and it didn't write the subsequent ones. It just broke. Like, that's why we put the break, and it broke, and then rendered this output. I have encountered a percentage. So this is good for us because now the program recognizes percentage signs. Awesome, guys. So it printed 4 characters. 4, only 4, because test is just 4. The other things were not considered. All right, so let's jump into...
Hello.
Yes.
Hello. In this case, now with what you just explained, can you hear me?
Yes.
I say, in this case, now, based on what you just explained here, that means in that first example you gave now, the tester wasn't 7 characters now.
It was 7 characters.
I don't know if I'm getting it right.
It was 7 characters.
It's 6 characters.
6?
Yes.
It can be 6. T is 1, E is 2, S is 3, T is 4. Did I get it right? I think I miscounted. Well, let me look at that case, please.
It's characters.
I think it printed less because of the break statement.
Hold on. main.c. Just hold on. It's not something hard to fix. Tester T1, 2, 3, 4, 5, 6. And new line. New line is 7 characters. So
Okay.
it actually printed a new line. New line is part of the character.
Okay.
Yeah. So.
Hello.
Yes.
I have a question. So what's the function of the continue in the loop?
The continue makes sure that once it finishes that place, it just goes back to the beginning of the loop and starts afresh. It doesn't read through every other remaining thing. You get the point now?
Yes, thank you.
All right. Now, guys, there is one more thing we have to consider. If there's a case where very, very special case. It's an edge case, but I just need to point it out because it's very important. It might give us unforeseen outputs if we don't consider it. Now, do you know that you can declare an empty string? It's possible, right? You can define an empty string. It's not null. It's not a null pointer. It's actually a string, but it doesn't have any character inside. Does that make sense?
Yes.
So, like,
come again, please.
You know, you can declare an empty string. Okay, I think we captured it. Yeah, we have captured it. Yeah, I just remember. We captured it. Where we said while format I, if at the beginning format I doesn't have anything inside, I think you should take care of that. I believe so. But if we see it in the real case, then we'll handle it. But for now, let's just forget about it. Let me not bring up concepts that will confuse anybody. Okay, so now the thing we are going to now handle is what it now does with whatever it sees. When it sees percentage D, what will it do? What should it do? What should it do? So let's take care of that. So that will
Felix,
come in.
just a question quickly.
Yeah,
For
go
the
ahead.
the first if statement prevent the passing of a null pointer. Right on top.
Yes, the first if statement.
The one where you say preventing passing of a null pointer.
Okay, yes.
So that one, shouldn't there be a break statement there also?
There's no need for a break statement. Return actually breaks. Return actually does the whole breaking. But break doesn't really work there. Break works within loops.
Okay.
Break and continue loop statements or things that we used to get out of loops for certain reasons.
Okay.
So I think that handles that. Okay, so this is where it gets a bit complex. Now, we are going to do something here. This is after handling this, we'll stop this for today. We'll stop this session for today. Anita, are you there? What's the time? How many minutes do I still have? Hello, my timekeeper. Who was keeping time?
Has she gone to sleep?
I think we have 30 more. Let's go on to sleep. We'll print F. Hey, we're joking. 30 more minutes, Felix.
How many more minutes?
Okay.
I have how many more minutes? I didn't hear what you said.
30. Let's take it to
wow.
7.
30 more minutes.
30 minutes.
All right. 30 more minutes it is then. So let's see what we can. Now, I am very sure what we want to do next will take that 30 minutes and still need more time. But we will be disciplined to stop at 30 minutes because of the people in the East. They are already getting to midnight. All right. Please mute microphones. Please mute micro. Okay, thank you. All right. So this is what's gonna happen here. If this guy comes in, which this all works, so I'm going to remove all this expression and stuff. We have confirmed that this is working, so I'm getting this out. Even the break, I'll take it out. And this print something, I'll just, okay, let me bring back my expressions. I'll just take out this one and take out this one. I'll remove expressions when I'm done with putting what is supposed to be inside. Now, what will happen here is whenever we encounter this percentage, we should look at the next character and see whether it is any of the things they said we should consider. You know how printf works, so it has to be any of the specifiers, C, S, I, G, and all of those. So we just have to check whether it is any of those. But in this case, they said we should only consider 2. So for task 0, I am going to consider only 2. But if you see how this is done, you can scale it to any amount of consideration. In fact, you can even bring your own homemade own that is different from what printf original has. So we're going to consider C, we're going to consider S, we're going to consider percentage. All right, so let me start with, now, let me now state another problem. In this case, if we want to do all this here, where I wrote expressions on line 37, is going to be so long that nobody can read through our printf function. So I have to break this out and send it to another function, maybe write another function. So the only thing that function should take is when we get to this point, immediately we get here and we see a percentage sign. What will feed into that function that will be in the expressions place is the next character. So that function is supposed to check whether that next character is either D or E or C, and then when it checks it, according to the character it sees, it will specify how it will be printed. You don't print integers the way you print regular characters. You don't print unsigned long, or there are so many types. Those types are handled differently. So the logic here is we get to this point where we see a percentage, which is what this normal, our regular printf function is doing. Once it gets to this point, in place of where we have expressions, we are going to declare a function that will take in the next character from that position. We are in format I. Format I in this place is equal to percentage. But we want to fetch the next character after percentage, which should be format I plus 1, which is the next index. Like for here, when I get to this place, percentage, I want to fetch D and supply it to that function that I will create. And now that function will now evaluate this thing and check, is D one of the specifiers? If yes, it will pull a function that will render that D to the screen. And as it is pulling that function will do something. That function is going to take in another thing. It's going to take in one of the variadic functions that we have already specified, or the user specified. Like in my case, when I specify D here, I already put a number 7. So it's a variadic variable that I put there. So once it gets to this point and sees percentage, it fetches the next character, sends it to that function that we're going to write now. The function will analyze it and say, okay, D stands for decimal. So I'm going to be printing a decimal. That function will go into our variadic list and send it to the standard output, and update count. That is what it's going to do for us. Does anybody have any question? Now, the thing in programming is not about the codes. You see how we're working. I am making mistakes. You guys are seeing them. You're helping me fix them. It's not just about the codes. We have come a long way, and we know so many codes. In fact, if some of us are already doubting themselves, but you've done so well thus far. So it's not about the codes actually. It's about understanding the problem in view, and then being able to apply the codes to it. So if you don't understand the problem, you will not be able to code nothing. So do we understand what is happening here?
Yes, so
we do. Okay. All right. So let's get on to it. Now, in our last session, I thought there was something I tried to explain. I told you guys it was very important. Now you will see how important it is. I said I was trying to teach how to declare very weird variables and functions and stuff. and how to read types in this place. I don't think so. So we're going to come up with our own thing. There's nothing here for us, guys. So we have to come up with our own thing. So I'm going to declare a very weird expression now. Watch and learn. Now, this is for the declaration. The other day I was teaching how to read it. So when I finish declaring it, I'm going to read it too, so that you see whether it conforms to what I taught. If you have the videos, you can watch it and understand better. So this is where everything is coming together. So we are declaring a function that will capture a character, which is the next index from where we are, because where we are is already percentage sign. It will capture the next index, and then when it captures it, it will do something within itself, and then return a function that will take in the variadic parameter that the user specified, and then send it to printing. And when it finishes sending to printing, it will count how many things it printed and return an integer. That is the count. So that we can always use it to update our count. Now, see that question, somebody asked me why I used value. In this case now, see, count again is coming into another function. If I used it straight from the upside, that would have been a problem. So this is how we're going to do it. So what do I call that function? Pick a random name. Let me call it format checker, yeah? Or specifier checker, or check force, check specifier, check underscore specifier. Have a name that conforms. So check specifier is a function. So this is how you do it. It's a function that takes in a character. So I'm going to use character. But in this case, do we take a character or do we take a pointer to a character? I think let's take a pointer to a character. But either way, it will still work the same way because it's not really overwriting it. So, but let me use a pointer in case I have need to overwrite it from within the function itself. So let's just use a pointer to a character pointer called that's the next index. So it's going to take format. Character pointer. What am I doing, guys? Oh. This is not where to declare it. I'm actually using it here. So I'm going to just supply what we should take. This is a pointer. So let me give it a pointer format. But this might confuse people. So let me create that function first. Please, guys, let's stop here. Let me create the function. Let's create the function first. But just know that the function is going to take a character pointer, and then it's going to return, analyze it, be sure it's a specifier, and then return the appropriate function that will take the variables from the user, the unknown parameters from the user, and then print it to the screen, and then return the number of integers or characters it printed. But there is something we have to consider here first before I go ahead and do that. I need to deal with the variadic function. We have not talked about that or dealt with that. So I have to declare the variadic list, and that is done with a macro. Have we put in the include file? Yes, we did put it in. So on line 19, I am declaring a variadic list. So it's called var list. Let's call it ags. Let me just call it like that. We have declared it. So I should initialize it, yeah? Let me just initialize it here too. Let me initialize it. How do we initialize it again? var start. Now initializing is like saying when you do int I, and then you now do I equals to 0. So this is more like defining it. But they provided a special way of defining variadic lists or pointers. So var start, it takes 2 arguments. The first thing it takes is the list itself, yeah. So it's going to take args. And then the second thing it should take is the last known parameter, which in this case, the last known parameter for our printf function is the format parameter format. So that's all. That is all. Guys, I hope I'm correct. I really, I'm doubting myself now. I hope I'm correct what I did. This should be okay.
Yes, you are.
All right, so let's proceed. Now, the thing, so in this case now, whenever we args can now be passed to any function as the list of variables that the user supplied, and then there is a special function to now be picking each parameter one by one, each variadic parameter one by one. So we haven't gotten there. There is no operation here that actually needs that, so we are not going to call it, but just know that we have declared and initialized our add list. All right, so from this expressions corner, where is it again? From this point, expressions, I'm going to pause here, and then we'll now go and create the function itself. All right, clear out the screen. And then I'm going to call that function or that file check specifiers .c. So another function has been added. The same way we do it. Let me start with my simple documentation. Avoid forgetting anything. So this is writing specifier, and we're supposed to check character, check check that character is a valid specifier. The valid specifier, and finds appropriate function for its printing. That means in this case we will now have different functions. When we have a character, there's a particular function that will print it. When we have an integer, there's a particular function that will print it. We'll write all those functions ourselves. But in this case, we're supposed to write only two for characters and strings, and the one that will print a percentage case. Okay, so what are the arguments it would take? It would take just one argument for now. It would take format. I'll just call it that for now. Specifier type. Which in my case should be a character. So let me just call it the character pointer just for clarity. And it's going to return a pointer. It's going to return a function. Should you return a pointer to a function or a function itself? Okay, it should return a pointer to a function. Pointer to function. Pointer to function. Okay. Now let's stop there. We can update it later. Okay, how do we now declare this check specifier? Check specifier is the name. Now, guys, if you don't know how this is done, please pay attention. else you get lost. Check specifier is a function. So I have to say that it is a function that takes character pointer argument, and then it returns, go to the return side, it will return a pointer. Now, all the functions that we're used to in all the tasks we've done thus far until the day we started dealing with function pointers are just functions that when you declare the input and then on the other side you just write int, char, this, the other one, size t. Those are very simple declarations. But now it's a little complex because the return type of what we're doing here, this particular function, is not just a primitive value. It's another function. It's returning another function, or it's returning a pointer to another function. So this is how it is written. So on the other side, you write a pointer, you put it in brackets because it's another function that is returning. So it returns a pointer to a function. So how do you say it's a function? It's a function. You specify another function bracket on the right that takes in var list type. We can put args, but we don't know the name yet. We know the name, but let's just put the type. That's what it needs for now. That's all. This is the declaration, guys. And then when it takes in var list, it returns something at the end of the day. So return types are put at the other side, at the left side. It returns an integer. So you see this declaration? This is weird. Now, the other day I thought how to read it. I said, am I still audible?
Yeah.
Yes, we can hear you.
Yeah, you're on.
Now, please understand what's happening here. Understand what's happening here. If you don't get it, whatever we're going to do within this function will sound like magic. This is a function called specifier. There's no way around it. This is just the standard way of doing it. There's no simple version. So you just have to force yourself to understand it. I wrote it easily because I know how to read it. So that's why I tried to teach that thing in the last session, in our last session. So find the video, watch it. Check specifier is the name of the function. How do we know it's a function? You read to the right until you meet a bracket closure, you stop. You read to the left until a bracket stops you. Then you go back to the right until a bracket stops you or you don't have any other thing to read. Then you go to so you read left, you read right, left, until you finish reading. And whatever you're reading, you store it in your brain because it will help you know how to use that thing you declared. So check specifier as it is. To the right is a function. That's how when I start writing it, so I specify as a function that takes an input of character pointer, which is a character, and it returns on the left, it returns a pointer. But it's not the regular pointers we used to know. So we now continue the declaration because we now have to establish a new bracket. So a pointer in bracket to, I read to the right again, to a function that takes in var list as the argument, which is the variadic things that we will pass into it, and returns an integer, which in this case, this integer will use it to return the number of characters in Printf. So that being said, we now know that this is a function. Functions have enclosures like this.
Can you please, excuse me, can you please recapitulate? Let's understand that, please.
Right. Okay, even if this is where we stop for today, if you understand it, it will make all the sense because from here, every other thing will be sprint. It'll be easy if you understand.
Hello.
Hello.
So what's the return value of the check? What's the return value of the check specifier? Data type.
check
So it checks
specifier.
in.
You see, as I highlighted, that is all there is to check specifier. Is a function that takes in a character, but then every other thing I put around this is around it is the return type. It will return another function.
Tom, your question has scared him away.
Who has understood?
Felix X connection is bad again, I think.
We need you now more than never before.
I think he's having network.
Hello, guys. Oh, network. Cool.
We can hear you now.
Okay. Can you see my screen?
Yeah, we can see your screen.
I'm already having my attention span is having a stack overflow already. So I think we should end this meeting and continue another time soon enough. So now, now what was I saying? When you're declaring pointers to functions, they are not declared the way we declare regular pointers. So watch. On this side, one regular pointer, int pointer a. This is our regular declaration. That means a is a pointer variable of the int type. But when you're declaring a function pointer, this is how you declare it. Assuming a is still a function pointer, I say a in bracket. You put it in bracket. Remember? So that's why this return type is in bracket. Because the declaration of function pointers are always in bracket. So see now, this is how it is. A is a function pointer that takes in something, maybe an int type, and then return a character type. This is how to declare function pointer. I know many persons didn't pay attention when we were doing that. Now all the concepts are coming into play in this Printf, and that was the essence of the project. Bring all the concepts together and test your understanding. So wherever you find it so difficult to understand, you go back to lessons and refresh your memory. Not even if it's complex. It took me several days to understand it. All right, so now at this level, this is how it's declared. This is how function pointers come. This is how the regular pointers come. So with this idea in mind, you know that whenever you say, I want to read a function pointer, brackets will come in, input types will come in, and output types will come in within that function that is returning it. Does it make sense now? So if you carry this and come in here, check specifiers is just the function we're dealing with here. But it's returning a function pointer type. So we still do it the same way we declare function. That takes in values and returns an integer. Okay. I wish there is just another way to break it down, but this is just the only way to say it.
Okay.
Yeah.
So hello?
Yes, I'm with you.
So since the return, you are saying that the return value basically is the int bracket check up input should be the VN.
can.
Yeah.
Just hold on. Let me just say this. Let me just finish this. If it was just a regular function, we could have just done this, and we're okay. We are okay. But in this case, it's a special type of function, so there has to be all those whatever around. Okay, please go ahead and explain what you want.
So to understand
so
functions,
just for the clarity sake, so if you bring back to declaration of functions, so we normally have the return type, the name of the function, and the inputs, and then since in our case here the return type is a pointer to a function, so the pointer. So the pointer in this case was the int star check specifier API. It takes the VA list, does not have a name.
So explain something. Function type, the function name, and the input of the function, right?
Hello?
To understand that. So to understand pointer functions, it's basically this name and in you understand so far?
So that.
Okay.
Exactly.
Okay. So I'll make an instance with what we have on the whiteboard. Now the function here is the A pointer, right? Now it's taking in an int parameter. That's the int you have in front of A. Now it returns the character it has behind it.
No, mind you, this is not really, this is a function pointer declaration, yeah. So
okay.
This is not really a function here per se, but it's the one on top is a function. So you can explain with respect to specifier.
Okay. All right. Okay, so the specifier, it takes in a character, right, as an argument.
Yeah.
Right, and returns the integer it has behind it.
Mm-hmm.
Yeah, so you know function. Yeah, okay, go on.
But the real issue, so we are supposed to be declaring a particular function, and this function is taking a particular input and is returning an output that I think. So this check specifier is this function that we are declaring right now is supposed to be taking a particular function, a particular input, which is the VA list, and then it is.
No. That's where you're getting it wrong. It's not taking in VA list. The function actually is not taking in VA list. It's taking in character pointer. That's where it stops. Yeah. VA list is part of the return value. That is, the return value of when you say a function pointer, is actually a pointer to another function. Yeah.
Sorry, Felix.
Okay, Felix, if you could break it down, you see the way you've illustrated the function type, function name, and the function input. If you can write the function type, what it is, the function name, what it is, and the function input, so that we can have some clarity. on the discussion.
Okay, now let me do something weird. To rewrite. Right. Guys, don't be offended though if you really understand this well and we are just stuck here. This is the key to printf. If we don't make sense of this place, every other thing we do will not make sense, and that's not the essence of this meetup. Okay, this is the function we are looking at. Complete function name, function input, but we don't have a return type. Yeah. So on the return type, I'll do something like this. It's supposed to be this. Now watch me. This will just make you understand it. This is actually what I want you to have in your head. Now remember, when I say character function pointers, we already know that this is the default way to declare function pointers. So what I'm basically saying that is check specifier is the function I'm working with. It takes in a character pointer, but then it returns this entire thing. I don't know whether this works in real life. I've not tried actually. I've not tried declaring it like this, but I might just be surprised it might work. But this is just the thing I was talking about. So check specifier is the function name. It takes character input and then it returns a function pointer. And every function pointer declaration has an input and an output. That's why it's looking so complex. There is no time you declare a function pointer without specifying the input and the output, because that pointer is supposed to point to a particular function, and that function is pointing to has an input and an output. So it has to prototype what that function looks like, or whatever function it wants to point to eventually. Whatever that function is looking like, it has to prototype it, like create a prototype of it. Does this make sense? By looking at this other one I declared up here, you can tell that the name of the function, and you can tell the input of the function, and then you can tell the output of the function. Yeah.
Yeah.
Beautiful.
Yeah. That which is clear. Yeah.
Yeah, that's exactly what I did up here. But
sorry, Felix.
Wait, hold on. Don't cut me yet. Now, but the rule of the game says when you finish declaring it like this, now watch me. If you ever get confused, you can declare it like this. Once you finish declaring it, carry that your pointer, just pack that your pointer, cut it, and put it inside here, just inside here. Pop, and that brings back what I declared earlier. So use the other map, this map, and always get this other thing.
Okay.
Does it make sense now? Just use this map I just made before. This one. Just use it like this. In your brain, when you're reading it, just see it like this. That check specifier is the function that takes in the character type and returns this. Now, the funny, okay, let me not go into that. It will confuse you more. So that's just the way it is. But
with what you just excuse me, brother.
Yes.
With what you just did here, just as if this is a kind of a prototype.
Which one?
Check specifier char.
Check specifier char is it looks like a prototype, yes. But well, you start with prototypes now. You now work on your function. So I can now have something like this, and then put something like this, and then now start working. Expressions now come in here. It's a function. So this is the function name, this is the function input, and this is the function return type. but the function return type is actually a pointer to a function. And pointers to functions are written in a specific way, which you have to master. This is just how it's written. There is no way around it.
Please, so, you send me your WhatsApp number, please.
If you get more confused, look at the materials on function pointers. That is where all this will be answered. But funny enough, this particular issue was not treated there. That was why I took out time because I also had that challenge. I took out time to explain it in our last session. All right, so that's for that. So now in this case, you just carry the function, and put it inside here. And you have the standard declaration format. That is
okay. If just for a bit, just to clear up, so if you are returning a pointer, for example, a pointer to a function, so if I am to write something of the sort, so maybe int bracket star the name of the function and then the input int star the name of the function closing bracket and then the name of the input. So that's the pointer function pointer.
Hold on. Say what you said again. I need to write it down so that I'll pick it. Int bracket
star the name of the function. So the name of the function in this case is the check specifier. What is it?
Yeah.
So since you are returning a pointer to a function, so if I'm to write something of the sort like int bracket star f and then the input to that function, because we are returning a pointer to a function, that function which you are pointing to will have an input and an output, right?
Yes. The pointer, the function you're pointing to will have an input and an output, and you have to also specify it.
So what's the input of that function that I'm pointing to? Input and the output.
In this case, why it's confusing here is because we haven't looked into the function itself. I'm just declaring this because I know that this check specifier is going to return another pointer to a type that will take in values. Now, values is a data type from our previous place. The printf underscore printf.c file is a data type. So this function is returning. The pointer to this function is the pointer is returning is pointer to a function that will take that as an input and then return an integer as an output. But the function we're working with here is actually text specifier that will take in just character pointer. But whatever is returning at the end of the day, we will fetch it. Now, we will fetch it using an equals to sign and assign it to something, a variable. And this variable is supposed to be a function pointer. So we'll fetch it. So whatever this text specifier will return is a pointer to a function. So we'll fetch it using f. And when you fetch it, that means you have fetched a function itself. That is function somewhere. So that function somewhere will have an input type and also an output type. So when you're declaring functions that will return functions, you have to, that return type, you have to specify the kind of input that return type, the function pointer is returning will take, and the kind of output the function is pointing to will take.
Exactly. So that was the question because
So that's what will happen here. So when we call check specifier, we will assign it to a variable. So this variable is actually supposed to fetch a function pointer, and the function pointer will have an input type and an output type. Yeah, that's what we all declared on this topic. All right, let's proceed. I'm glad it makes a little sense, but when we're done, take time to actually look at it privately to make more sense. Guys, I'm going to stop here for today, but let me just do a little, when I say just, I still keep going deeper. Now, we have finished declaring this function. So what this function will do is check specifier will fetch us a character type, and that character type we will check it against a set of. Now within this place, what we are supposed to do is we will have a function that prints characters, a function that prints strings, and a function that prints percentage something, anything percentage as specifier type. So we are supposed to actually have three functions somewhere written already. So we're going to write that later. So within here now, what we'll do is there are two ways to achieve it. Many persons are afraid of type def and struct. Very, very afraid of it because it gets confusing. But it's actually very simple to use, and it's one of the simplest ways to actually approach this. The other way to approach it is doing something like this. Let me pull up this. We can do something like this. Create two arrays. Let me draw a table. Use it to specify two arrays. Now, we can create two arrays this way. So the first array will, the array in blue will take those characters that we're checking against. You know, this is checking specifiers. So this first array will take C, D, S. Those are the things that say we should consider only three for now. C, D, and percentage. Yeah. Then the second array will take for at the same index of C. The second array will be array of function pointers. The first array will be array of characters. This one will be array of function pointers. Now, so this one will take, this other one will take at the same index, print string, and this other one will take another function name, print percentage. Now remember, they said that the name of the function is also pointer decays to the address of the function. So that's why I'm just writing the names of the function here. But we've not written these functions actually, but we'll write them using exactly those names. So this is one way to approach it. So we can write two arrays of the same size. The first one will hold characters. The second one will hold function pointers. So now when we get into this function is already coming with a character. Let's say it's coming with a character S. So we will find a loop structure that will loop through this array. The first part of this array is to check the same index. It will check the first array. Is there a C? No. The character I'm coming in with, say, is an S. Is an S character. So it checks the first index, which is index 0. Is there an S? No. It will move to the next index. Is there an S? Yes. So if there is an S, yes, that is at index 1. It will go to the second array that holds functions and print and return index 1 pointer. So it will return this as the return type. Remember, the return type of this function is a function pointer. So it will return print string. So now within our main function, we will now do whatever we want to do with that value that is returned, which is actually a function. So we now use it and now manipulate our printing because we need it to fetch us different functions for different character specifiers. That is actually what this check specifier function should do. Fetch us different functions for different character specifiers. So this is one easy way to approach it. Just that here we'll be working with too many indexes, very many arrays, and all of that. Now, the second way to approach it is to write a type def. which is, this one looks more professional, but that doesn't make it simpler or better in any way. But professional programmers would prefer this way because that's why these structures were made. So another way to do it is to create a special character type that encapsulates these two things together. Instead of putting them in separate arrays, it will encapsulate both the character and its function. Character and its function. Character and its function. So the struct is going to be a special type of struct. Say struct. Let me click this a little bit. Okay. All right. So struct. Let's call it a name. Let's give it a name. Functions. Funcs will create now supposed to take in. I want to be seeing both of them here. Should be better. First, it's supposed to take C. It's supposed to take a character type. This a structure that will encapsulate both of those things together in one single variable. So that's what structs actually do. So it's a composite data type. So it encapsulates things. It gives you the ability to encapsulate things into a single entity. So C, it will take a char pointer, call it T, and it will also take a pointer to a function, something like this. Pointer to a function, as we said before, that will take in values of integer. So this is another approach. So whenever we declare this kind of struct, we will now instantiate it. That means create variables from it. So if we now say, let me use a type def, please. Let me use a type def and change the name to something else that I can manage. F in the struct to more. Down here to say func T, func type, function type. So func T. We call it just func. All right. So now next thing is for me to find a way to instantiate it. Now make different capsules of these different events. I'll make capsule for C and its character pointer, function pointer. I'll make a capsule for S and its pointer. I'll make a capsule for percentage sign and its function pointer, which is its function. So these capsules are called instances. So I'll instantiate the structure. So I could call this func T type. One that then at the beginning. Func T. Just give me some random name. Func T C character type. Let me just use their names. Instantiate another one. Func T. What guys? Oh, it's func.
Func, please. Func. That's done to see. Func.
That's func T S. Func T. So I'll just create different instances. Now, each of these instances, remember, this is just like declaration. You have to assign values to them. And this is a composite data type, so it has two values. You have to assign two values within it. First is the character symbol, and the other one is the pointer. So for this one, for the func C, I will assign a value, say, you put it in this kind of bracket. First one, I'm going to assign C, going to be character C, comma, it's not a string, it's a character, C, and then the next thing is print. What is the function it's supposed to show? Print char function. Print char. Then on this one, I'll do the same thing. C, put it here. Then this one is going to take a character S and then return in string, something like that. So I have created instances of that type, and I've assigned values to them. So now the last thing to do is I have to put this in an array form so that I can.
Wait, Felix, what of the percentage?
Yes, I also do for the percentage, something like that. Copy. So these are why I'm saying this is these are just two approaches to it. I don't know the one we are going to use. Everyone has its own challenges. This is more professional. The type def and struct is more professional, and that's why they want us to use it, or why I would want us to use it, since we just finished learning about it, so that we'll perfect the knowledge. But so when we finish like this, we'll now pass this into an array. Now, the essence of the array is just to make sure that we can access them individually. So it's just array of types. Array. So it's an array that will hold a func type. Func T array. Then will be equal to, I'll now pass all of this into it. 3.
Please, sorry, Felix.
Hold on, please, don't cut me yet. Don't cut me. Let me not miss something. Here, then I'll now pass it. Now, this is just a long way. Why I did it like this so that people don't get lost. There's another shortcut to read the same func thing. I'll pass B, S, and the percentage sign here. Whatever it is. But this is not supposed to be a variable in the actual, so maybe I use P. I don't know, or percentage PC. Print PC. This should be PC. This works. So indexing. My array 0. I'll land at this struct C. And this struct is a composite type that has a character C inside it and a function pointer inside it and a function held inside it. So when I'm comparing all the things that this particular function will bring in, when I'm comparing the character type, I will have to look through this array I created here. I'll have to look through it, check the first index. The first index will bring me this structure C. I'll check whether that character that the function brought in is C. If it is C, I'll just return this function to the outside. But if not, I'll go to the next index, check for S. Is S equal to the character that function brought in? If it is, I'll just return this particular function to the outside world. But if not, go to the next index. That's another way to do it. It's more composite. But in this case, I have two arrays. I'm going through both of them at the same time. So the first one, I go through this. If I find a match, I use the same index number and pull a pointer from here, from the next array, the second array. So it's just two ways of approach. This one looks simpler, but we may still come across structs later. So I think we should stick with one approach. If we're going with arrays, we will have to stick with arrays all through. But when we now meet struct again, if we meet struct, that will be another challenge. So I think we should just go with struct so that we'll master it as we go. So that in case we have need for struct again, it will be easy to access. And with struct, we can always, it's easy to instantiate it from any function. That's just the two approaches. So that depends on which one we're going to use for today. Majority carries the vote. Guys, which one should we implement? Am I still audible?
I think the structure is better.
Using the structure.
I think structure.
Yes, you are.
Okay, I've heard too many struct. So we go with the struct way. All right, so we land inside this function. What we now have to do is to create a struct. Remember, we don't have any struct anywhere. We could have made it local to this function, but we will be accessing those. We could have need to access those struct instances anywhere within the entire program. So it's good to put it in the header file as part of your declaration. So instead of putting it to be local to this particular function, I'll put it in the header file and then bring in the header file here so that wherever that header file is, the struct is there. Anybody can instantiate it from anywhere. So with this, I think I've even gone further to explain two things: instantiation of structs, how it can be handled and stored and all of that. So if you have the video, go back, look at it, and you will understand it better. So let's implement the other one. So now I will leave
your voice, I'm not hearing your voice.
And good. Okay. Am I audible now?
Yes.
Yeah, I mean that. So that has brought a second thing to our header file, which is the struct. In fact, it's bringing three things. After the struct, no, before the struct self, we already declared a function somewhere. So I have to bring a prototype of that function here, which is checkers. So I'm going to still write it the way check specifiers, right? Guys, let me copy this for the fish. I don't want to make mistakes. Debugging it can be a pain in the ass. So let me just pick it from. Let me copy it. Let me copy the way it is. And then that saves me the hassle. All right. So after that, we now have a struct. So I'm having a struct here. Struct. Let's call it func. That was the name I chose. Just a random name. What is it going to look like? We have an character type, character pointer. Should be a pointer. Why should we use a pointer? Why should we use a pointer? So that it could be a pointer, it may not be a pointer. Please take note. Right? Okay, pointer, yes, it has to be a character. Char pointer, yes, it should be a character. So the type. It's a character, so it has to be a char pointer because characters are char pointer. This is a function pointer, so I use an F and the function pointer that takes values, argument, and returns and an integer. Then I close my struct, write a little documentation for it. I really don't remember how struct documentations go, but it should be something like, guys, how do struct documentations look like? What does it look like, please? I'm losing my voice. What does it look like, please? Quickly.
Have to write first of all what the font is doing.
Okay.
And then, like a short description. And then the members you declare, like, you show the members in the description. And then the last description is telling what the struct is doing in full.
Okay. So, no, what I'm confused about is, at this point, do we write the name in full? Why I'm saying this because of Betty. I don't want Betty to...
Yeah, I know. It's just funk, right there. Just funk.
Funk, yeah? Okay. Structure struct for printers and printers. For character, for specifier, printer, something more descriptive.
There should be struct before the name of the struct in that documentation.
Okay, there should be struct in front.
Yes.
I don't remember how struct documented. I don't remember. So I told you we're doing this from the scratch. So that should be it. So the members. The first member is T.
Felix.
Yes. Character to.
Oh, but this file you're working on now is the main.h file, right?
Yes. We're declaring a struct.
Does it contain such? I thought main.h file contains only the prototypes.
Yes, now struct is also a declaration. It's a prototype of a struct. So this is prototype of our struct that we'll be using within files.
This is shit. Man, you have to drop your this for me, please. Your WhatsApp number, please. Okay.
Okay, that's not a problem. If you are in our group, we are all there. So if I'm not there, there are.
What's my name there?
Hello? I didn't hear what you said.
What name are you bearing there, please?
Felix.
Okay.
My name. Somebody can drop the link to the group. Somebody's saying something. I can't hear the person. So let me continue, please. I should remove the underscore. Oh, yeah. Thank you for that observation. Thank you. I think character to compare. And at F should be the function that handles the printing. Function handle printing. I think that's all. Struct do not have return types and all. So let me stop here for now. If there's any amendment, we can do that later. So this is our struct. I think we're done with this. So we have the declaration of the struct. So we can now go into our this thing and instantiate the struct. But let me use the typedef. Yeah, please, guys, let me use the typedef here. I think that will make sense. And reduce the name to something else. Use the name to call it funct, so that whenever you see funct, you know that we are making reference to this our data structure. This is perfect.
Let me ask.
Yeah, ask.
Yes, Eric, I can hear you.
Go ahead, ask.
What does it offer to this struct font now? This typedef you put there. What are the features that is giving this struct font as you put that type def?
The features.
What is enabling the struct font? Because you said you have to add type def in front of that struct.
Do you know what type def does normally?
It's not in my head. I know they know. No.
Okay. You should go and research on that. Assignment. Okay. And the next class will give us. Once you research on it, you will be able to understand what I did, so that we don't waste time here on that.
Okay.
It's a very simple concept. Okay. So I'm leaving this place and I'm going back to our check specifiers. Okay, so we have a struct. So I will now start to instantiate. Now, yes. Where, which file, here or where I came from? I can't hear you well, please.
We can't even hear the person. Is the person speaking from this platform?
Yes. Your microphone is very, very, yeah. Not so clearly, but just speak.
The previous file.
Yeah, okay, the previous file.
Yeah, you need to add a space.
I'm there.
Add a space here where you have renamed the struct, the func t. Add a space between the curly bracket and the func.
Okay.
Yeah,
Does
yeah.
that really matter?
Yeah. Betty.
Oh, okay. Thank you for that. Betty can be, Madam Betty can be an issue. I still wonder why they gave it a feminine name, because women can be troublesome. So back to this. Now we are going to instantiate. But now there are two things we can do here. I want to keep it simple enough. We can do it the way I did it, where we will write out everything we need, assign values to it, instantiate them separately, and then assign them to an array. Or we can actually create an array and just instantiate them within the array automatically, so that we don't need to have to give them names separately and all of those. So I'm not going to do it this way. If you have the recording, you can go back and see what I did here. It will still work the same way, but I'm going to do it the easier way, just to keep our code concise. So is going to be an array that holds func t type. This is confusing me again. Func t. My array. For now, let's give it a size of 3. Since we're only considering 3 specifiers. Don't go beyond yourself. Just keep it where they say we should keep it. There is room for expansion. So this is where the magic happens. An array is supposed to take characters one by one, but in this case, we are instantiating all the struct. So for each index, we will instantiate a struct there, instantiate, the same way we did it here, you see. So let me just copy this even. I could just copy this, copy it like this, and then paste it here, yeah? So I'll remove this semicolon at the end. So that is one. I've instantiated one. In this case, I don't need to give it names like I did func t this, func t that. So the array will handle all the naming using indexing. So this happens. I go down. I have to instantiate another one. I go to copy the next one. I copy the next one without the semicolon. I come back here. I place it into this place. Correct? Good. But I have to line it properly so that I don't make a mess of everything. Okay. There has to be a comma. Now, these are array elements, so you have to put commas. The next thing I have to consider is the next instance, which I didn't really capture here properly, which is supposed to be percentage. Okay, func PC. Okay, I'm going to. I need a unique name for that one. Can someone come up with something so that I don't want to use that percentage sign? It could be misleading to the compiler, especially if we have to use it for some complex implementation. So this is percentage sign, percentage character. Print, what's the name for this function? What do we call this function eventually?
X. X.
X.
Yeah.
Okay, print X. No, X can mean hexadecimal.
Okay,
So,
okay.
Just add cent to the back of the P now.
Add what?
Cent. Like the P and cent. C-E-N-T. So it's more descriptive that way.
A cent. Okay, beautiful. Or cent. Print cent. Oh, thank you. That sounds a lot sweeter. Okay, I think this is all they say we should consider: character, string, and cent. Print cent. Now, this is where now the logic gets funny. What do we now do with all these things we have instantiated? We will have to create a loop structure again. Now, what will this loop structure do? Get that character that is coming from check specifier function, compare it against this particular struct character. If there is a match, spit out that function. If there is no match, move to the next index. Check that that character is still the same thing, is equal to this character S. If there is a match, spit out the print string. If not, go to the next one, check for compare, and then if there is a match, spit out that function as the return type. Now you now see why the return type of check specifier is a function pointer. Spit it out as a return value. But if not, we'll also have to figure out a way to handle the if not situation.
Sorry,
Anita.
I have a question.
Yeah, go ahead.
I was a little bit confused about this percent when we're checking here on the function. Can you
Go
hear me?
ahead. Yeah, ask.
Okay, so I was like, since it is the one that our condition is based on, why are we still returning a function for the percent?
Okay, now see why that is. Let me answer that quickly. We were considering different scenarios for. Have I removed that thing? Our printf. Okay, now this was what I used before. Yeah, we're looking for S or D or I or something. But what if there is a case where you have percentage and then followed by another percentage? What happens? So there should be something to handle that.
Oh, okay, I get you.
So it sees the first one, then it looks beyond. If what it sees again is the percentage, will it still look beyond, or will it just pass or stop? There has to be a way to print that situation.
Okay, I get
That's
you.
what
Thank you.
That is what that function will handle.
Thank you.
Yeah. Okay, so guys, my head is. Do we pause here for today? I am tired.
Sorry. We are doing hard things.
Yes, let's stop, please.
No, let's stop.
We die here.
function and then you can
Just me.
Okay. See what I'm going to do.
Possible to finish task 0?
It's not possible today. But it's not. Task 0 and task 1 are very simple. If you get task 0 done, the way I'm seeing task, I've not done it. I've not done it. Sincerely, I've not done it. The way I'm seeing task 1, the only thing we have to consider there is writing print functions for each of those ones. For I and for this, there's nothing much to consider. Then for task 2,
then let's finish this one.
We may not finish, but let's just finish this particular function, check specifier function. Let's just finish it.
Yes.
At least let it be that we arrived at something. Guys, let's pick what do you call it again? A loop structure, while loop, for loop. Which one will work best for here?
Let's use for loop.
Let's
while.
Go ahead.
For will work faster.
None of them works faster actually. It's just the one that is convenient. But since we know the size of the array we're working with,
use while loop. While loop it will be more illustrative.
While loop, I hate using while loop when I know the size of what I'm dealing with. While loop is a lot difficult to handle. But for loop, you see everything from the beginning. You will be like the super bean. See everything from the beginning. But for loop, you may need to have to do a lot of checking and see where to put an increment. And if you don't do that, you will land yourself in a funny loop that will loop forever. Okay, so I need a bottle of Coke.
Yeah.
And since I can't get one,
you don't get Coke.
How can we send it?
All right, so let's use a for loop then. Since for can give me, let me see the end from the beginning. For I, now I said don't declare any variable until you need it. For I equals to 0, now we have just declared something, so I have to go and we have used a variable that is not declared, so I have to go and declare it up there. Let me go up there and say int I.
Your screen, someone sent Jumia food to Felix's house.
All right. Somebody said you can't see my screen. Is my screen still visible?
Very visible, yes.
It's very visible.
You can see it.
Okay.
Okay, so now what are we really comparing here? We are comparing this character with every character of. Now there's something we did not handle here. I'm thinking so. What if since we're dealing with pointers, anytime you're dealing with pointers, always consider the null case because it can make your program crash. A null case, especially with pointers, because null is also a pointer to null. So we should also consider a null case. What happens if some guy sends us a null pointer as the character? Oh, let me consider that, please. No, not inside here. What am I doing? Yeah, I'm thinking out loud, sorry. Let's just loop first. If there's any error, we'll see it. For this, for I, that is equal to 0. Now, how do we end the array? To I that is less than. No, this is. Somebody should help me here. My head is. There should be. Okay. Okay. Let's do it this way. Let's do it this way. let me put a null case here. Why I'm putting this is I don't want to use this number. I don't want to really use this number because this number will always change. When we increase, when we'll be considering more cases, we'll be changing the value of this 3. And I don't want each time we change it, we'll have to rewrite the function again, right? So I have to find a way to keep looping until I hit something that I know. So let's put that to be null. So let's create another struct that will point us to null in both cases. So our struct should be something like this that takes a null as the first n, and also that's null as the character, and also returns null as the function. So if somebody sends us a null pointer, this function is going to handle it. Now, it's going to also serve two purposes. Without needing to look at the size of the array, I can just loop through this array. So I loop index 1, index 2, index 3 until I hit a null. If I hit a null case, I'll stop. I know that I've gotten to the end of that array. Does that make sense, guys? That's just the way I think we should handle it. So this is my array. My array dot I, or my array I dot t is not equal to null. Now I will explain what is happening here. And if that is the case, do what I need you to do and then increase I by 1. And that should be good enough for me. Do this. Then I do this. There's an expression. Okay, let's explain what's happening up there. Integer initializes to 0. I usually don't like doing this inside here. Please let me remove it. This initialization by doing it here. No, let's do it inside here for readability, for ease of reading. So for I equals to 0, then check that my array.t. Remember the struct we created, the t for each struct. So my array I, my array 0 is pointing on line. Let me put those lines again. Right. So my struct, my array with index I equals to 0 will be pointing at line 14. Yeah? So I need to get
You know that tutorial, you don't give us projects. We're very mad, though. Mad, though.
Hello?
Mute your mic now, please.
I need to get into that array and then find character C. So I need to be checking once it's looping through these characters and it gets to the character pointer null. Stop. Don't go again. That means I've gotten to the end of the array. So my array index 1 or index 0 is pointing here. Dot T. So this structure, the T part of it, remember the T is, if you check the header file we declared, the T is the name of that member inside. So .T will give us C. So in this case is my array.T, which is equal to C equals to null. No, it should do again. To go to the next one, check for S, check for this. Then the point where my array 0, 1, 2, 3, my array 3, index 3.t is null. That is line 17. This program will stop looping because it will assume that is the end of the array. So that's why I put that condition here. So as long as we have not hit null for that particular case, please keep increasing and keep looping. whatever we'll be expressing within it. So I'm going to express a couple of things, and where another set of logic will come in. Okay, guys. Now the work is pick if what this guy supplied, if what the check specifier function supplied to us is equals to format, then return the function following it. Else, it will just, I don't know, just to check that the function did not fail, maybe return something else. But for now, let's just implement that. If my array I is equal to math I. Guys, I'm missing something here. This doesn't have a name. Okay? It's crazy. Yeah. But I don't have anything to reference. So let me call it format. So I have to reference it now. So now, at that point up there is a declaration. So it's just telling us it's a pointer. But if I call it format here, it will just be a pointer with an address. But what I don't need, what I need is the value within it, not the address. So I have to reference that address and get a value. So if my array I is actually line 14 at this point. My array I is line 14 at this point. So I don't need the entire structure. I need a particular member, particular entity of that particular structure. So I need the character within that structure. So I will have to get into that structure with a dot and then look for the t value, which is the character itself. So if my array I dot t is equal to the format that the function came in with, then that means I have found what I'm looking for. Just return that goddamn function within that same struct. So what you now do is return the outside world, my array I dot. This time around is not the character that we're looking for. We're looking for the function. You remember we did t and rf. So we look for my array I dot f. So it returns the function. That's the function pointer. Sends it out to the rest of the world. So that is what there is to this stuff. Then in a case where this happens and we don't have
your semicolon. No, you forgot your semicolon.
Oh yeah, thank you. My head is already. Okay, so
let's put it now.
Yeah. So in a case where we finish the whole thing and we are not able to see a specifier, we should also return something. We should just as a checker, probably. No, we can't return anything. Sorry. We can return null. Since this is a pointer, we're returning pointers, pointer to function. We can return null. Just return null. Can't return a number, sorry. We can return null. Null is a pointer, sort of. So, I think this is all there is to this function. So guys, look through it and see whether it makes sense.
Yeah, where is the point F from?
From our struct, the struct we declared. From our struct. Our struct looks something like this. Let me pull it up so that you will see it. See, this is what our struct looks like. So I have T representing the characters and F representing the pointers or the functions. So a function is held within a function pointer. All right, so that is that for this. Quite unfortunately, there's no way to test this particular function we wrote until we are able to write these print functions. And then once we write this one, and this one, task 0 is complete. That's the only thing that's remaining here. So, but we'll handle that maybe tomorrow. I'll check my schedule and see if there is time tomorrow. But after we're done now, I'll push, thus far we stopped, I'll push everything the way it is to a GitHub repo, Printf, and it will just be there. So you can go look at it at your spare time or continue building from here if you now understand what's happening. But I believe thus far we should.
Felix, before you exit, the array number should be 4, isn't it? Instead of 3, it's supposed to be 4.
1, 2, 3, 4. Yes, thank you very much. It's 4. It's 4. Okay, that's 4. That's 4. All right. So, any questions thus far? You see, someone said something yesterday. Was in the group. Our PLD teammates said, was it a private chat? I don't even remember how I got that thing. Said, Felix, I looked at this repository, I looked at this file, and the thing was just so full. I just couldn't analyze it. Today we started from blank sheet, and now let me go back and let's see what we have been able to achieve. That is just how programming is. Once you have the algorithm in your head, keep pouring it out into codes, translating it to codes until you have something. So today we have ended up with 3 files. A printf.c file. We have a check specifiers.c file. We have a main.c file for our testing purposes, and we have a main.h file. Guys, remember, you do not push main.c to your official repository.
Your voice is lost. Let's find your voice. Please bring back your voice.
And I really missed a lot too.
Bring your voice. Come back. Felix, come back.
All right, so for this particular case, I'm going to send my main.c file to the repository, but close to the time that checking will happen, I will hide it. I will copy it into another folder so that when they use the wildcard.c, star.c, it will carry the main.c and want to compile it. They will supply a main.c for every test. All right, that's all for now.
Felix,
So
can we test the check specifiers?
Can we test what?
The check specifiers to see if it works.
We can't test it yet. Why we can't test it is where we stopped in the development. Now look at our check specifiers. We can't test it because when we want to test this thing, it will call for this function. If you want to compile now, it will look for this function. You remember, this is supposed to be a function pointer. This function does not exist anywhere. at the moment. So we need to create this function. We need to create print char, create print str, print sent. In previous projects, we've done something like print car. It's just straightforward stuff.
Okay, and when you say we have to create the function, we create it as a file and then
yes, we create them as independent functions. Yes, we can create them into another central file as just a library of functions, but I would prefer to create them as independent files.
Okay, yeah. Good.
All right, so that's why I cannot compile it now. If I compile it, it will give us error. And the only way to fix the error is to build those functions. Unless you want me to build empty functions, and we don't have the time at the moment. So we'll do it. We'll continue from here probably tomorrow.
Okay.
But as much as possible, we will do our best to finish the mandatory tasks before first deadline, which is on Wednesday, I believe. It's 2 days from now, yeah? Or a day plus.
A day plus, maybe 2 days from now.
Okay, so we just
a
do
day
what we can.
plus.
So probably tomorrow we will do that. Tomorrow is the public holiday in some countries. Nigeria has public holiday tomorrow. I don't know for some other countries.
Well done, boss.
So this will appear in. I'm not going to put the A dot out. I'm going to remove it. But the rest of it will be. Let me even remove it now. Who has microphone on, please? I'm removing it. So the rest of these files will appear in my repository this night. This is where we are.
Put the main.c. Put the main.c.
I'll put everything. We are not done with the main.c. We'll build more tests.
Yes.
Eventually. Yes. So
what of this Microsoft Word? Will you put it in your file in your GitHub?
It's on the recorded. Whoever is recording will capture this. I will not be able to put it. But these are just the two I've put. If I had time, maybe at my spare time, I will develop another checker specifier function using this particular format. It will look a lot simpler, but I don't know the cost effect in the future. So that is it. Wow, a lot of persons left us behind. Wow. I remember I tried coming into this event and the thing was full. I had to wait.
So some people cannot stand any longer now. Either sleep or one thing or the other.
It should.
Okay, guys.
We do hard things, right?
Before you
Vic, before you go.
Your GitHub, okay.
GitHub. You can even copy it from here at once. Official Mr. Pelly.
Put it together with your WhatsApp number, please. So it's very important.
WhatsApp number is very important.
Drop the link in the chat box.
All right. Yes, that's what I'm trying to.
That will be easy. Lower the sound.
Okay, I believe you. Oops. Okay, I just dropped it. I am waiting for it to push. Okay. WhatsApp. +234 0 0 5 0. This thing keep popping up now. It's just so annoying.
What is that?
The notification. Very annoying. You see what I'm suffering? That's very annoying.
Google Meet they tire for you. They see plenty people they tire for you.
Okay, WhatsApp. Felix Bianazie. +234 305 I believe that is it. So
You believe?
What? Okay, it's the chat box. But if you're in the group, if you're in our PLD group, you don't need to even have it. You can just save.
What is the name of the PLD group you're talking of? Let me understand that.
I don't know. There are so many PLD groups out there.